Hello.
Hello,
Welcome
yes.
back, sir. Welcome back, Dr. Krishna Purna. Welcome
Hello,
back.
hello, Dr. Rajan. So, how are you?
Fine, fine, nice. Thank you. Thanks for joining sharply.
Yeah,
So, participants being lunch, they are slowly joining. So I think we can wait for a few minutes and then we can start.
yeah,
If you are,
no problem.
yeah, yeah,
That's okay.
because after lunch, as usual, no, people will join a little bit. It's our culture.
But if there
Sorry,
is
yes.
any, but if there are any other questions from others,
Yeah, that they can ask. No, like,
they can
yeah.
ask now. No problem.
Yeah, participants, yeah, you can post your questions. Sorry, sir, because yesterday he said he will take questions on the next day. So you can post your questions, whatever session given by him yesterday, by Dr. Krishna Purna. You
If they
can
know
feel
what,
free to ask.
if they also know what I'm doing today, they can ask me questions.
Yeah, yeah, that is that's a different thing. Please interact with him, sir. We'll start in another 5 minutes.
Yeah,
Sir,
sure.
over time you can start in another 5 minutes. Okay,
Yeah,
2 5 you
yeah,
can start.
yeah.
Fine.
Fine.
Thank you.
Good afternoon, sir.
Sure, Vishal?
Yes, sir.
Okay.
Good afternoon, sir. I welcome you to our SCTP program for day 3, session 3, sir.
Thank you.
You should start our session, sir.
Yeah. Okay. You able to see?
Yes, sir. It's visible, sir.
Okay. Thank you once again. In continuation with what we were speaking yesterday, so more emphasis on sustainability, durability, and things like that. So one of the other products that we have developed is asphalt rubber. Some of you might be very familiar with rubber modification in binder. In fact, rubber modification is very much prevalent even in concrete, for that matter. Now, one of the things that you should understand is with respect to pavement deterioration. Okay, when we see that the roads are getting deteriorated. So yesterday we talked about the life cycle analysis, right? Now, one strategy to preserve these pavements from further deteriorating is to have different kinds of products that will help as strategies for pavement preservation. So why we have to do this? The reason is simple, so that we don't incur cost at the end of the design life, number one. Number two, we don't want to have accidents. If you have too many potholes, that can lead to accidents. You people are very familiar with that. Number three, the more you let it go, the more is the problem for the underground layers, the underneath layers. Okay, so all of these aspects are detrimental to the system as a whole. So it's a systemic approach that we are looking at. Okay, so when we talk about the long-lasting pavements, one very important aspect is to preserve, or what we call maintenance. Right? We do routine maintenance. We do. It could be a preventive maintenance. It could be a rehabilitation. It could be an overlay, and so forth, so on and so forth. Now, one product that we that's there for almost 50 years now, okay, is asphalt rubber, where we have been blending crumb rubber inclusions. I'll talk about the sizes when we get there. Okay, with asphalt cement, or what we call the bitumen, right? So this has been a very popular product across the world, in fact, and it has become very popular for several functional reasons. One reason is it has the capacity to mitigate tire pavement noise because of the rubber granulates that are there, right? The rubber inclusions which are there within the mixture, they have that absorption capacity. Now, when you start using these kind of products, there is also the other aspect coming from the environmental engineering, where we are trying to use or reuse the discarded tires. Otherwise, what happens? They just take it to the landfill, they shred it or burn it, incinerate, which will actually cause environmental burden. There will be huge amount of gases that can emanate, which is not a good idea, right? And it'll actually put a lot of burden onto the environment, smoke and so forth, that you people have heard of. So there is that environmental stewardship that comes out of this product. Now there are also problems with this product, which I'll share with you later. That's what is the first module in this presentation. And then the second thing I thought I should share with you is on the pavement asset management. It's not just construction everywhere, right? Not just building the infrastructure, but also we need to make sure that we preserve our assets. How do we do that? We need to be monitoring it. So we do a long-term monitoring, we do a short-term monitoring, and then we need to also come up with strategies based on the budgetary constraints. Okay, so for this kind of a road, this is what is the strategy. It could be 1 year, every year it could be done, every frequently 3 years it could be done, it could be 6 years, it could be at the end of design life. It depends on what the roadway agency really requires. So we have been developing a toolkit for the state of AP, Andhra, wherein we have got data to the tune of almost 14 lakh data points. I'll, I'll share with you how did we use that data, and probably this is the first of its kind in the country, where we have a very good tie-up with the state government, and they have given us data, and we'll be giving them a toolkit. In fact, it probably could be extended to the other states because we have been successful, and I'll share with you our thought process and framework. Okay. Okay, so again, these are the 3 or 4 modules. Yesterday, I already spoke about this sustainable pavement technologies. So I'll not emphasize, but one thing you should understand is RAR, rubberized asphalt rubber, because this presentation talks about asphalt rubber, right? That conference is there in Spain next year, and then we bid for it for India, and we actually were successful in getting it for 2024. Okay, now there is also the other conference, Smart Cities, which also talks about all of these different strategies, pavement preservation, and then pavement asset management, and many, many other things. Again, very much stressing on this need that we really have to be doing, academia industry partnership, where the industry comes forward, says, okay, we have these problems, can you solve this for us? So that's the client-based approach, and it's a very successful model across the world. Okay, okay, and this conference coming up next year, so please visit the website, you can get more insights. Now coming to the asphalt rubber as such, okay, what is asphalt rubber? How do you define it? What ASTM, American Society for Testing and Materials International, the society is very clear that a blend of asphalt cement, or what we call bitumen, right, and crumb rubber inclusions, the rubber content within this blend should be minimum of 15% by weight of asphalt cement. Otherwise, what happens? You cannot call that material or the blend asphalt rubber. Now you might get a question. We have CRMB in the market, right? Crumb rubber modified bitumen across the country. Any refinery or any company that you talk about, they all have CRMB 55, CRMB 60, and many other variants. Now, what happens to that? Is it called AR? The fact is, they are not AR products. The reason is simple. If you talk to them, they'll tell you, okay, we have rubber blend. It's anywhere between 8 and 12%. But ASTM is very clear. It's a global standard, been adopted across European Union, in Singapore, Australia, Canada, North American countries, and then South America, of course. So all of these people have been using, and also Middle East, I forgot to mention that, and Africa. All of these continents have been using asphalt rubber standard definition by, what does it say? It says here, you can see that at least 15% by weight of the total blend should be rubber. Otherwise, you cannot call it ER. Now, so what is happening here? Is it the dearth for rubber particles inclusions? Not really. We have enough abundant tires that are being discarded in India too. So what is the problem then? There are problems associated with CRMB. There are 2 major issues. One, storage. If you just keep the rubber modified binder, I call it rubber modified, not AR as such in India, because I told you it's not 15% minimum, right? So we call it CRMB only, crumb rubber modified bitumen. Now that when you start storing in asphalt storage tanks, what happens is it starts to get settled down in the tank. If you don't agitate and have high temperatures, it'll start to settle down. Then what happens? You have lighter fractions on top and heavier in the bottom, which makes it much more difficult to blend it homogeneously. So that is one major issue, why we don't have good skill and why we are not able to do the shearing action. So that there's an RPM, a minimum of this number, and the time, digestion time that is required to blend this asphalt cement and rubber. Now the other problem is oxidation. If you keep it exposed, okay, asphalt rubber blend or CRMB in India, what happens is it's so volatile that you will actually lose some of the oils over time. Then it does not serve the purpose. So major problem that we have is we don't have the good skill, and also we have not done enough research in this area. So based on my experience, international experience, what we have seen is asphalt rubber as a product by itself is an excellent material. It could be for a preservation, it could be for a structural layer, including the bottom, base course. It could be a dense graded, open graded, gap graded, all kinds of gradation is possible with asphalt rubber. Now CRMB, one of the things that people have done in India, and and that's one of the reasons why, you know, people have not been successful, is they have been using this CRMB with dense graded gradation. If you people are familiar with what is dense graded, gap graded, open graded, you know, I'll just give you briefly what it is. A dense graded gradation is simply that you have all kinds of sieve sizes starting all the way from 53 millimeter until about 75 micron, which retains on the pan, right? You people have done sieve analysis, you should know this. Now, if you have all kinds of gradation, it becomes a dense graded. So there is beautiful interlocking effect. So all of the interstices, or what we call the voids, the porosity, those get filled with the smaller particles, which is why it becomes a strong material. It's dense. Now, if you talk about the gap graded, you have too much amount of fines. So there are a few proportions of sieve sizes in the middle portion that gets eliminated. So it becomes a gap graded. And one example of gap graded, if you are very familiar, is the SMA, stone mastic asphalt. That is also a gap graded. It's a cousin. Okay, it's cousin of our gap graded structure. Now, yesterday that we talked about pervious concrete, that's a gap graded gradation, because you have larger sized and you don't have fines, and it is leaning towards open graded, which I'm going to define now. Open graded is single sized. It's just uni-sized gradation, and that usually is used as a surface wearing course, because it provides that porosity, very high porosity, and that's why it is able to drain water. So the porous asphalt that you see, okay, porous concrete, porous asphalt, they're all open graded to gap graded, leaning towards open graded, obviously. Okay, now when you start using these rubber inclusions, or any foreign material for that matter, for all your research purposes in future, based on our experience, what we have seen is as follows. If you are using a foreign material such as rubber, fiber, steel, or any other material, okay, in asphalt blend, you need to have enough space to accommodate this. I'll give you an analogy to understand. Let's say you have a class of 50 students, okay, you have 50 seats, obviously, with the professor standing and teaching, right? And okay, for now we are having an online, so you people are, there is no restriction on how many can participate. But if you are in a physical setup, obviously you have only 50 in the class, and you cannot accommodate a 51st person to sit. He can enter, he or she can enter the class, but they cannot sit, right? Why? Because there is no space, there's no seat. Now, that is the same story here. So you are having rubber inclusions in the asphalt mixture blend, which calls for additional space. And if you are not providing additional space, there are two problems. One, drain down, the other is bleeding. So that's how you have rutting and shoving and many other problems. Cracking also can take place, and then finally pothole, right? All of these problems come because people have used CRMB with dense graded. So this is a question that I've been asked across the country by many agencies, and we have been working on this. And I've been telling them, don't use CRMB as such in dense graded. It is not going to be successful because you don't have enough space. So you need to be coming up with some other unconventional gradation to accommodate these rubber inclusions. One example obviously is open graded, and the other is the gap graded. Okay, so understand this. This is the background. So these are some definitions. Now, how much of rubber inclusions in the blend? You see, it has to be finer. You see, 100% of the particles finer than the demarcation line that distinguishes between coarse aggregate and fine aggregate, right? That's the 4.75 millimeter sieve. And it has to retain on 2 millimeter sieve. This is what is the rubber particle size. Now, people have actually gone even lower than this. Some of them actually have gone even until about 300 microns. It's very much possible. And that's called the fine graded, right? Fine rubber graded. That's very much possible. Now you see one catch. Why it's a very popular blend? Because asphalt cement has a specific gravity of 1 or 1.01 or 1.02. If you talk about rubber, this is not the natural rubber, please note, okay? Natural rubber specific gravity can even go until about 4 that you get from the trees, right? Kerala has a lot of rubber plantations. If you get the rubber from there and then start preparing, it has a very high specific gravity, which is good in terms of enhancing the strength, but then you cannot blend it with asphalt cement. It's not going to work for you. So if you're blending rubber inclusions, when I say that is coming from the discarded tires, that when it is blended with asphalt cement, Okay, it is compatible. Why? You see, specific gravity is 1.15. I told you 1.01 for the binder, rubber is 1.15. They're not very far from each other. But still, this is slightly higher, which is why it can settle down. That's why that settlement issue is always there. So there is that handling issue and then the settlement issue, right, within the asphalt storage tank. So these two are very important problems that are prevalent, where we are not very successful in the country. But some people have been blending CRMB, and then they've been using it with, I told you, dense graded, which is another successful failure. I call it successful failure because people have failed in blending that. Okay, now when you say 15% by weight, universally people have used the Arizona gradation. Okay, Arizona blend, which calls for about 20% rubber inclusions by weight of asphalt cement. And let's say you have 80% bitumen, 20% rubber, that makes it whatever, right? 100% asphalt rubber blend. And that is the number that we use when you do the Jobix formula. For example, if you're blending a gap graded asphalt rubber, the binder content can vary anywhere between 6 and 8%. Okay, you people are familiar. If you go to the Indian Roads Congress specification, it says for the dense graded, the binder content shall be 5%, anywhere between 4.5 and 5.5%. Right here, you see it is a rich binder. Why are we making it so rich? Because there is rubber inclusions. The whole intention of using this product is you like to have no cracks, no rutting, no oxidation, no moisture ingress, right? So for that, you need to have rich binder that makes it rich in terms of having higher binder. Now you might ask me, so what happens to the cost? Obviously, cost will increase. Are we looking at initial cost or life cycle cost? That's the next question. So I'm posing more questions to you to kindle your thought process, but also for you to ponder. Okay. Now, if you talk about the open graded asphalt rubber, so gap grade 6 to 8%, open graded, which is much more porous in nature, the binder content will vary anywhere between 8.5 and 10%. You see, much more richer. It has more space to accommodate more amount of rubber. So go ahead, use it. And we have been very successful in blending both in India, also in our own laboratory facilities, and we have also tested on actual field sections, which I'm going to share with you. So this is what is the prologue of what we will discuss today. Okay, and you can see the AR technology has been very well used. One very good strategy as a pavement system. It's a systemic strategy, and this has been acknowledged by several experts across the world. Okay, you have a very strong base course with PCC, Portland Cement Concrete. Okay, and then you have a very thin asphalt rubber friction course, ARFC. And that's a blend that we have, that's a combination, composite structure that has been successful across the world. One problem here is slightly political, okay, is you see you have this Portland Cement Concrete in the bottom. Now the cement industry comes and says, okay, we placed all the structural layers all over the place, we put concrete, and you're putting one small layer, thin layer asphalt. Now I cannot see this, obviously, right? So the concrete industry says, oh, we are not able to see the concrete that we place. So what happens? But you see, you should go beyond that. The systemic approach is, this is only half to 1.5 inch, which means only 25 millimeter. It could be even less than that. 12.5 to 25 millimeter section on top of the PCC, which could be even 600, 500 millimeter thick. So it's a strong structural layer in the bottom and thin functional layer. What is the advantage of this? You see, after, let's say, 3 or 4 or 5 years, let's say it has started to ravel, which is unlikely. Okay, with asphalt rubber sections, I have seen with my own eyes, there are a few sections which are about 25-year-old without even a single fine crack. And I'm going to show you one section that we placed in India, near Kharagpur. That section lasted for about 2.5 years with the design that we put, without even a single crack. After that, it cracked because of the traffic that humongously increased, which I'll share with you later. Okay. Now you see, This is a very thin section on top of this. So functional layer giving you the good skid resistance, higher porosity, so no water splash, so hydroplaning effect is reduced, no accidents whatsoever. This is one strategy. The other is you can have asphalt rubber in any layer in asphalt system itself, flexible system. Asphalt rubber friction cores, asphalt rubber gap graded. This is a gap graded. AC is asphalt rubber, asphalt concrete, which is a gap graded asphalt rubber. Friction cores is an open graded structure. Now the porosity of these top layers, surface wearing cores, can vary between 16 and 23%, 24% also is possible. These gap graded structures can vary anywhere between 7 and 11%. That's the porosity. Dense graded, you people are familiar, it can vary anywhere between 4 and 7%. Okay. In fact, even the IRC specifies 3 to 8%, which is what is the ballpark that we have. Now, where all can we apply this asphalt rubber product? Hot climates, cold climates, no problem, because it has that rubber which can help in self-healing. Okay, and this I also call it perpetual pavements for the simple reason that it can last for a longer period of time. Okay, and it can serve the entire design life without probably any maintenance or minimal maintenance, I should say. In fact, we have seen some sections without even a single crack. There are a few sections in cold countries where I have seen, because I worked in Europe, we placed asphalt rubber there also, and we also saw some cracks. It's no doubt there are cracks during the winter season, especially the low temperature thermal cracking, but then it started to self-heal. That self-healing capacity is coming from the rubber resilient property, because rubber is resilient in nature. It's elastic, right? It can come back to its original. So benefits, humongous amount of benefits. You can see multitude benefits here. Reflection cracking or reflective cracking, what we call. We have the concrete in the bottom. There are cracks near the joints. Obviously, joints are vulnerable to cracks. You have an asphalt overlay. It simply goes up. Now, if you put asphalt rubber as a semi or what we call the stress absorbing membrane interlayer, it can arrest cracks. Less maintenance, I told you, more durable, obviously. Raveling, no raveling whatsoever, because it is so rich in binder that there is no dry aggregate whatsoever. It's rich, 7 to 9% binder content. Good rut resistant. Question, right? Some of you might get, oh, it has high amount of binder, it can start to bleed, but we are placing this as a very thin section, maybe 25 to 50 millimeter. You can expect very least rutting on these sections, mainly because you have larger sized aggregates which can take up the load, and it can help in arresting rutting also. No problem with cracking. I told you this, self-healing. Skid resistance, because it is open texture or gap texture. Definitely smooth ride, very good ride comfort. And I showed you a picture both in cold climates and hot. In fact, I was there in Arizona and Sweden. I have, in fact, in 1 year, in 2010, I have seen, I have felt actually, I've experienced 70 Celsius pavement temperature in Arizona, and I moved to Sweden in the same year where I saw minus 46 Celsius. So you can see a range of temperature, and we have seen asphalt rubber in both conditions working very, very fine. In fact, less splash and spray because of high porosity. Noise, that's something which is a very good topic, research topic for you people to explore. In fact, one of my PhD was about tire pavement noise and using asphalt rubber to mitigate that. So you can go through that if you wish. Cost effective, I put it in blue because that's where that LCA comes into picture. If you call cost effective, it is not initial cost. Obviously, your initial cost will be very high because of high binder content. But very importantly, engineering use of old tires. So that becomes a very sustainable strategy. If you have a lot of tires that are discarded, don't burn it. Use it in asphalt rubber blending. Okay. If you need to know more about asphalt rubber, how it is blended, how much of rubber content, what is the gradation, what is the process, wet versus dry, all of these, you can go to this asphalt rubber standard practice guide. This is free to download. Go to rubberpavements.org. Okay, and I'm one of the co-authors there. In 2012, we released this document. Here it is, asphalt rubber standard practice guide. You should be able to get this. If you cannot get it, let me know. I will share it with you. Okay, now one project that we did. Okay, I'll get into the actual point. So we had the Government of India Department of Science and Technology project when I was at IIT Kharagpur for about 3 years. 3-year project where we actually developed a mixed design procedure and implementation plan for asphalt rubber gap. Now you see, I'm talking about asphalt rubber only, not CRMB. CRMB is a different blend. I told you 8 to 12%. It is not. It does not fit into the definition of ASTM. So whatever I talk from now on is about asphalt rubber, meaning minimum of 15% crumb rubber inclusions by weight of asphalt cement. That's what it is all about. Okay. So asphalt rubber gap we wanted to develop. What is gap here? It's a gap graded gradation where there is a lot of fines and some portions in the middle are removed, the aggregates. They are all larger sized, obviously. Okay. Okay, now we wanted to make it suitable for several traffic and environmental conditions in India. So we developed this from scratch. So the question that you might get, oh, we already have Arizona, we have California, Sweden, Florida, Texas, there is Chinese asphalt rubber blend, European blend, all of these. So why do we have to do this? The reason was simple. We have to do it in-house. You cannot simply borrow the product. It becomes much more expensive for transportation, and you simply borrow it from there. The rubber inclusion that they use may not be similar, may not be having similar properties that we have in India. The gradation, the aggregate property, the source of aggregate, the blending procedure, all of this will change in India, right? And the temperature and environmental conditions which have no control. So we wanted to do it from scratch, and we were also the first in the world, to the best knowledge of us, of our team, we were the first people in the world to use super pave mixture design for asphalt rubber. In fact, even Arizona and California don't use super pave yet for asphalt rubber as a specification. They still use Marshall mixed design. You people are familiar with Marshall mixed design. So we fully went into the super pave design, and that gave us a lot of confidence, saying, okay, this product will last for this many number of years. That we checked with our lab facilities and all lab experiments, and we went to the field and implemented also. Now we also wanted to create a standard protocol which is now pending with the DST. Okay, now if you need more about what asphalt rubber blend is, if you don't want to go through the design guide, there are 2 different papers. Okay, one that talks about state of the art research. It's about research review. Okay, one of my PhD students, past PhD students who worked at IIT Kharagpur, now she's a professor at IIT Palakkad, Dr. Veena Venudharan. Okay, yesterday I showed you about pervious concrete. He works at IIT Bhubaneswar, and this person actually works at IIT Palakkad. Okay, and then my other colleagues from the US and Europe. Okay, and then the other state of the art that we recently published in 2020 in Resources Conservation Recycling Journal. It's a very popular journal. Both of them are very popular, in fact. We talk about what is the advancement. Where do we use this blend? Can we use this blend in dense grading? That question always is there, right? So we always have been saying, okay, gap, open, asphalt rubber. What about dense graded asphalt rubber? Can we use it somewhere? Yeah, that is what we are doing right now. So our team is now working on coming up with strategies where we can simply blend rubber modification into dense graded, and probably a dry process where we don't really have to worry about having it to be agitated, storage issues eliminated, oxidation issues eliminated. So we are now working on it. In the next 2-3 months, if you people call me back again for another lecture, I'll be glad to do that. We have a PhD coming up on a new product, new range of products on asphalt rubber, where I'll share with you how the advancement is taking place. Okay, now let's go back to this DST project. This is the formula. Okay, this is the final outcome of the report where we actually came up with a new gap graded gradation. Okay, you can see here. You see here, there are a few sizes that are missing. That's the beauty of gap graded. And there are a lot of fines. You see here, anything below 4.75 is all fine aggregate, correct? You people are familiar. You see the number, it's really large. The numbers are, this is all percent passing. If you calculate the retained, that will amount to 50%. Okay, that's why it is a gap graded gradation. Large amount of fines within the matrix. Now, one other thing that you should understand is the nominal maximum aggregate size was 19 millimeter, which is a large size, obviously, and that actually helps us reap the benefits of structural capacity. So that is the load bearing is coming only because of the aggregate. right? And this 19 millimeter size actually helps us with that load bearing capacity. Obviously, you see that 12.5% also is of larger number, 35% retained. So that's also in higher proportion, right? The other thing that we did, we blended a binder. So we customized a binder for our own sake. If you go to CRME 55, CRME 60, I told you it's about 8 to 12%. I told you that will not be fitting AR definition. So we went in with a new design. So we started all the way from 5%, 10%, 15, 20, 25, 30. So we tried all of this. This is a PhD work. You can imagine how much of work the candidate had to do. So 5, 10, 15, 20, 25, 30, we actually reached a saturation point at about 25%. So 20, 25, 30, they all reached a saturation level in terms of stresses and strains. Okay, and we actually tried with state-of-the-art equipment. We found that they are all, that blend 20% will be ideal for us, and that is what is the definition of AR also, right? Minimum 15%. So we were able to capture that. Now we also blended, we also came up with the gradation of the rubber. So 300 micrometer. That's something very important you people should understand. Okay, and we came up with the super pave mix design, which makes it much more robust and strong. Why? I'll tell that in just a minute. You look at this air void structure, 4 plus minus 1%. That's the field air voids. In the beginning, you will actually see about 7 to 8%. Due to compaction, it comes down to 4%. So you reduce the density. Obviously, you're trying to optimize the density using a compaction roller, right, in the field. Now, binder content, rich binder, 7%. So we tried all combinations, 5, 6, 7, and in between also. So we came up with the optimum binder content using the super pave mix design, and we found that 6.3 to 7% is very ideal, rich binder for this gap graded structure, which will last for at least 12 to 15 years in the field for that design purpose. Okay, and why super pave? That's something you people should understand. Volumetrics, some of you might be familiar with volumetric phase diagram, right? What we have been doing so far with Marshall mix design is we calculate the volume of the total matrix, what we call VMB, bulk, right? A sample that is there in cylindrical shape, you calculate the volume, and you obviously calculate the specific gravity also, GMB, right? And the other thing is the GMM, theoretical specific gravity of the loose mix. So each and every aggregate particle that you can measure, GMM, we call that, right? Now, if you take the combination of these two, you get the air whites. So that's all we have been doing with Marshall, right? You calculate the GMM, GMB, and VA or VTM in some textbooks, or AV in some textbooks, air voids, volume of air, voids in the total mix. All of these are combinations. All of these are used in various textbooks. Now, VMA, what is VMA? Voids in the mineral aggregate. So how do you define that physically? I'll just take about 20 seconds to define this. That might be something interesting for you to understand. It's basically a combination of the air voids and the effective volume of the binder. What is effective volume of the binder? That is basically, you put binder into the matrix and then you coat each and every aggregate particle, correct? Now, when you start coating each and every aggregate particle, can you measure separately for each and everything in lanes of kilometers? Impossible, right? So you take a sample and then you measure the air voids. That's all we do in Marshall. What we do in super pave is we apply a kneading action when you simulate dynamic loads, and then you make sure that each and every aggregate particle is coated with asphalt cement, which makes it VMA. That's the volume of the mineral aggregates that are coated effectively with binder. That's what is VB effective. In some textbooks, they call it VFB. Okay, same thing. Voids. Okay, voids in the mineral aggregates or voids in the effective binder. VB effective plus VA will give you this VMA. Why is it so important? Because you see, for us, the coating of the aggregates will determine how much of material is dry, how many aggregate particles are dried out, so they will start to ravel out. So here there is no raveling at all because you are having very high value. See here 17%. Now the effective binder volume is about 12 to 13%. Air void is about 4%, so that makes it 17%. If you look at the dense graded, the effective binder volume will be around 8%. The air voids will be around 3 to 4%. That makes it 12%. So here it is about 5% more. So that makes it a rich mixture and having very high amount of binder content. Very good without, it'll arrest traveling, cracking, rutting, and so forth. Okay. Now, a demonstration test section I thought I'll share with you. Okay, so we came up with this design. This is an actual test section. It's a cross section of a road, of a state highway. Those days state highway, now it's a national highway. Okay, very high traffic road near Calcutta. Okay, so we talked to West Bengal Highway Development Corporation, and they were benevolent. They gave us this section where they said, okay, we will have a very thin layer. You can see here, it's only 40 millimeter asphalt rubber gap. That's our product, overlaid on DBM, WMM, GSB, different gradations. So we did not change any of these. We only did the topmost layer. That's the AR gap. Okay. So you see here, AR gap 40 millimeter on top of several layers that are already existent. We didn't do anything with that. We applied a tag code. So now here you can see the demonstration test sections. So we have we had about 250 meter of two sections. So there were two sections. One was 5.3% binder content. The other was 6.3%. And the 6.3% lasted for 2.5 years. And we told them very clearly that 5.3% we will try it for your sake, because that is very closely related to the control mixture. And you people know 5%, 5.3% is what we use for a dense graded control mixture. Okay. So we said, okay, that is also required. So we put control section, we put 5.3% asphalt rubber gap, we put 6.3. So there were three sections that we constructed, and you can see all our engineers. And one important construction practice that you should understand, for any thin section, this is a general thumb rule. Okay. And some of you from construction industry, if you are there here, and if you're going to advise some of your colleagues and friends, when you have a thin section such as this 40 millimeter, 50 millimeter, or even 30 millimeter, okay, don't use a vibratory roller. Use only a static steel wheel. If required, only use pneumatic tire. Otherwise, just use a static steel wheel, run the required number of passes, and finish off the compaction. Don't use vibratory roller. The reason is very simple. If you use a vibratory roller for thin sections, what happens? Your aggregates will start to get crushed. They will break into pieces. Your voids that is there, that you have designed in the gap graded, all of those will get filled up with these small particles. And you have defeated the purpose of gap graded or open graded, or for that matter, the thin section design. So very important. Don't use. So we told the engineers, you can see the engineering chief and the contractors, all of them here, and we were actually monitoring ourselves. The quality control was being done by us. So we said, please don't use vibratory roller. They were actually very furious with me, but I said, no, you cannot use it, because it's a very thin section. They've been used to using vibratory roller and pneumatic tire. I said, don't bring in both. Use this without vibration. That means it becomes a static steel. And you see the smoothness that was achieved at the end. So you see in June 2017, so we had one paver doing the job, and we actually calculated the required number of passes. Finally, this was the product AR gap mixture surface from a very close-up view. Okay, June 2017, very smooth, very well done job by the contractor. And this is the trial section. You can see asphalt. This banner still holds, is still there. Asphalt rubber gap graded wearing course 40 millimeter. That was the design that we made. Okay, a joint program with West Bengal Highway Development and IIT Kharagpur. Okay. And here is our team. So some of my students are also there here. Some of my MTech students and the general crew that was helping us. Okay. Okay. Monitoring. We monitored that for about 3 years now. In January 2018, when I had moved to IIT Tirupati already, okay, we took some pictures. I went there back, and then I took some pictures. You see there, this section is where we built. This is the control, all potholes, same road. Okay. No pothole here. Okay. And then in this also, I think the same year, you can see the control sections, they had fatigue cracks, Nothing on our sections. Okay, in November 2019, which is very recent, about 1 year ago, these pictures were sent by the West Bengal people, PWD. They said, yes, your sections actually slightly had fine cracks, so we had to patch it. The reason was simple. The state highway that we designed became a national highway. Okay, the traffic was not, we didn't design for a national highway. So we are now capable of designing it for national highway. And it will last, I'm telling you, it lasted for 2.5 years without even a single crack. So if you are telling us you design it for national highway, we will give you a product that can last for at least 8 years minimum. That confidence there. Okay, that's about asphalt rubber. We'll take up some questions if you have. Now let me go into the pavement asset management. Okay, the project that we have with Andhra Pradesh Road Development Corporation. So, and we are actually developing a toolkit for them based on artificial intelligence, artificial neural network, and so forth. I'll share with you some 5 or 6 modules that we have already developed, and then how do we go with this forward. Okay, talking about pavement asset management. Okay, I told you this. Pavements deteriorate over time. If you don't do anything in between, it'll simply deteriorate, as you see in the red curve here. Let's say you keep doing something in between the design life, right? You do preventive maintenance, slightly comes up. It still is good. Corrective maintenance comes up further. Minor rehabilitation, for example, a small overlay, such as the one that I showed you just now, right? Pavement preservation. You can arrest cracks. You can actually have raveling removed, all of those things that you can do with asphalt rubber. That's a very good pavement preservation strategy that we have tried. Okay, and you have all cracks and raveling, potholes, all of those that can be arrested with simple minor rehabilitation. If you have a major rehabilitation, that means you are going to rip off the entire section, mill it, you mill and fill. That's what we do. If that is there, then you actually incur large amount of cost, right? So that is exactly where this pavement asset management toolkit will help us. What happens at the end of first year, second year, 10th year, 15th year, and so forth for both asphalt and rigid sections, concrete, right? Okay, and this assists in decision making depending on the budgetary constraints that we have within the road. So if you look at the history, it all started in 1950s during the Asher road test that was done between 1958 and 1962 in Lafayette, Indiana, USA, where they had several test sections built, about 800 sections built. They ran the trucks, different trucks, and that's how the ESL concept, equivalent standard axle load, single axle load or standard axle load, that comes up, right? And they came up with different designs of CBR and many other things that came out. So within the same project, they also came up with this asset management. And they came up with something called the present serviceability index and rating, also the condition rating, right? Ride comfort. All of those were the products or the outcomes of the Asher road test. That is being used universally now. And then 1965, that's what is the PSI, Present Serviceability Index. 1970, they actually came up with a management system, long-term pavement performance studies. In the US and elsewhere, we call it LTPP. Okay, and it's still running right now in the US. Okay, and then Washington State DOT, they came up with the project level, apart from the network level, they came up with the, and then good roads, obviously they came up with the statements, good roads cost less, which means you need to be maintaining it every now and then, so you can reap the benefits of the entire design life there. Okay, and in 1979, they had an NCHIP report on this pavement asset management, and that became a national level, or it actually became an international level workshop on pavement management systems, PMS. Okay, and then they came up with the guidelines in 1990s, which also got into the Ashton 1993 guide, okay, in both asphalt and concrete. And now we have this asset management toolkits based on the IRI, International Roughness Index. So now they can correlate with roughness. That is the other thing that they have actually done. Okay, now there are several modules within PAMS, okay, Pavement Asset Management System. Obviously, you need to be collecting data. That's the first step. It's a circular process, obviously. You continuously collect data on cracking, pavement condition, okay, pothole, etc., etc., etc. And you create a database. We call the database management system, DBMS. Okay, And then you detect the various distresses using either manual survey or windshield survey, or as the case may be, using computer tools. With a mobile app also is possible nowadays, right? Okay, that DBMS and data, they talk to each other using some kind of network. That's the communication. Then we predict the performance of the pavement sections based on some numerical analyses and toolkits. Okay, that's the other step, based on the actual data. Then you come up with the alternative design strategies. That's the recommendation that I showed you: preventive maintenance, routine maintenance, minor rehabilitation, and many, many other things. One other advantage of PMS is, because you have the data, you should be able to calculate the costs also. When it starts to deteriorate, cost will start to increase. Right? If you don't do anything for 12 years, finally, when the pavement fails, you will have to invest a lot. That's the cost comparison of alternatives. Then you do the prioritization based on the budgetary constraints that we have. And finally, implement the strategy that we have come up with. So now we are actually working on all of these at IIT Tirupati, and I'm going to share with you 5 or 6 modules. So what we are doing right now is, we have data that we have collected from AP Road Development Corporation. Okay, and then we are coming up with strategies. Now, I told you there are 2 different methods. One is the automated, the other is manual. You have a profilometer, you can measure that. There is a network survey vehicle, okay, that is available in India as well. So that has different cameras embedded within the van, on the top of the van, and lasers in the bottom that can measure the profile, lateral and longitudinal. And you can also do a walking survey. We call that manual. That's what this person is doing. Windshield survey using a car. We have done that also many, many times. Now, one thing that we have got data, you can see IIT Tirupati director and me with our common student, okay, Pavani, she's finishing up PhD with the toolkit very soon. If you call me again, as I told you, 2 or 3 more months, you will have more insights about what we are doing. So you can see our large group here. We have this network survey vehicle from AP and Telangana state. Both of them have this. In fact, this has run across the country also. IRSM is managing this. So they have 3 cameras mounted on top of the vehicle. There is a laser sensor there. You can see that in the front. That is capturing the lateral profile. Now, what else they have given us? They have given all kinds of distresses that they have measured. Okay, fatigue cracking, different severity levels, different extents. Okay. And what we have done, what they have done, I should say not we, what they have done is, they have actually captured all of these distresses, but then they have put it into sheets. They don't know what to do with it. So they gave us this data. We said we will come up with the distress prediction models and give it to them, so that they can come up with strategies based on the budgetary constraint. If they have 1 crore for this year, which of the sections out of whatever number of sections that we have in the entire state, how many sections have to be done immediately? How many sections have to be rehabilitated? How many sections have to be used for preventive maintenance, so forth, so on and so forth, right? So this is a major drawback. It's a very tedious job just to have this in sheets. So instead of that, if you put it into DBMS and then come up with strategies based on some advanced techniques such as AI, machine learning, deep learning techniques, you should be able to hold this data forever, right? And I say forever, for at least a long period of time. Now, if you want to know what is PMS, if you don't want to read a textbook, go to a paper. You can see Pavani, who is our current PhD student. We published a paper recently in Automation in Construction Journal. You can go there. You can get this. It's a long paper, but it gives a very comprehensive literature, about 180 to 190 papers that we have actually collected reports. That is all together. So you can get new ideas, new prospects out of that. Okay, so there are 5 toolkits that we have developed. Another 10 minutes, I should be able to finish this. Bear with me, please. So first thing, on pothole detection. So we are now able to detect potholes. We are able to quantify how much of material is required to patch that pothole and also maintain that. The second thing that we have developed is probably the first of its kind. It's a published document now. We have come up with a distress detection strategy with almost 18 distresses. You can imagine 18 distresses, right? It's a multi-distress detection system, we call it. It's a comprehensive study that we have done using almost 6 lakh images coming from the state. And then we have come up with engineering criteria based pavement condition index. We have gone one step ahead of that, and we have come up with the deep learning based road roughness prediction model, which is also a published document. And then a biparametric homogeneous, this also. So all of these 5 are now published. If you want me to share with you, let me know later. So we are able to predict the distresses and also come up with some strategies. Okay. So I will start with the first module, pothole detection. You know what is a pothole? I'm not going to talk about this. All of you are very familiar, right? You have more potholes. You can see that you will have more accidents, obviously. And the cost exchequer on the insurance companies is very large, to the tune of $1 billion almost, right? So the maintenance cost will be less. If you're putting less maintenance cost into the system, you'll have more accident cost, and the compensation going to the customer, right, or the user from the insurance company. So you need to be very careful what you are looking at. So you can see there are different kinds of potholes. So we were very successful using an ANN, artificial neural network. I'll not go into details because it's already published. Please go to this if you can. You should be able to read and understand what we have done. So we had a lot of images, approximately 6 lakh images. So we found there were a few images. So this is all coming from the AP state. Okay, I'm sure Tamil Nadu and many other states also have these kind of data sets. We are now working with Kerala state. We have come up with an agreement that we will work with them and then give them this kind of a toolkit. If you know someone in your state, let me know. We will help them out. Okay, so we are doing it for the entire country, so we can help them. So we actually had the image data set. We pre-processed it to suit our architecture. We used YOLO, you only look once. That's the YOLO architecture, we call it. Okay, it's a version 3, slightly old, but still a very robust architecture, wherein we were able to segment the potholes from the images. You have a large image, you need to detect the pothole first. That's the first step, right? So that's called the pre-processing we did. And then we created a bounding box around the pothole and calculated the extent of the pothole. Finally, measured the depth of the pothole and told how much of material is required to patch that pothole. So you can see here there are various steps. We came up with so we have the original image. We pre-processed this, okay, and then you see this is the original image with high resolution, right? And then we had a tensor quantity. I'm not going to explain this. You people have to read it. Lack of time, obviously. And we came up with different classes of pothole: low, medium, and high severity, and also extent. So we had 9 different pothole types. We came up with 3, so that it's easy for the network architecture to read 3 instead of 9, because it becomes really cumbersome to read otherwise, right? And then we came up with the data dimensionality with 7. So that's a 7 A multiplied by B multiplied. So that's the 7 angles that we can actually measure, right? That's a tensor there. So you can see that we can measure the bounding box. So for example, this is the actual image. You put it into the YOLO architecture, you computerize that. So you give the architecture the different programming, right? You need to program that in such a way that it will have different layers embedded within the ANN, artificial neural network, and then it will detect the bounding box, and then it will also label the pothole image. So this is the large image that we have, and it detected the pothole that's here, right? And it also labeled, called it L, which is low severity pothole. If it were medium, it will call M. If it was high, it will be H. So depending on what kind of pothole type it is. So finally, we segmented the portion, and then we came up with the amount of material required for patching. That's a factor. This factor is there in the paper. It's anywhere between 15 and 25%, depending on the thickness of the pothole. So it's a 3-dimensional view. Now you see a 2D image became a 3-dimensional product for us. So you should be able to get the pothole class coming from our network, and then factor that's already there, how much material, right? So here is the chronology of the events that we followed. I just mentioned this to you. And then we validated that. Okay, we found the number. It was 89.23%. It's really large. You see, our numbers are really confident now because we had a very small decay, and also the learning rate was 0.001. That's 1 into 10 power minus 3. It's really large. On 41 images, we just tried with 41 images and we published this. Now we have actually come up with more than 1,000 images. Okay, we have also published that. We will share that with you maybe in the next couple of months. Okay, now we wanted to check that if there is any other algorithm, mean average precision, right? That's mean average precision that you see with one of the other papers that was there, that's already there in literature. It's slightly higher than theirs. Okay, ours is slightly higher than what they had, 88%, but still substantially better than theirs because of the architecture that's robust. The second thing that I thought I'll share with you, which is also a published document, it's going to be presented in Transportation Research Board in January, next month, in fact. We have a multi-distress detection system that can detect about 18 distresses very easily. Okay, and again, we trained this using YOLO version 4. So we slightly advanced ourselves. Okay, and we trained and validated on diverse data sets. When I say diverse, there were 3 different data sets. One, the LTPP coming from the US, long-term pavement performance. The other is the German data set. The third one is our AP state. Okay, all the 3 images, all the 3 data sets were combined to get approximately about 1500 to 1600 images. Now you see, this is exactly what AP state gave us. Okay, so we had the real time, you can see that, right? 3 different cameras. I showed you a network survey vehicle that had 3 cameras mounted on top. So all those 3 that were capturing these, plus a side camera that captured, the bottom camera that captured the roadway profile when it was moving. So all the 4 data sets were used by us. We captured the images. I told you we had more than 6 lakh images. We boiled it down to about 1500 images where we had different types of distresses. And these are the things that they gave us. Apart from just this, all of the other things that they gave us, and we are working on it. So 3 data sets I mentioned to you: long-term pavement performance from the US, German data set. You can see the number of images that we had, right? 5,000 plus, 4,000 plus, and then the Andhra A, that we call A data set. We had 800 images that had different distresses. So what we did, we again pre-processed it because we had images and videos. So we had to convert it to grayscale. Otherwise, it's difficult to read by the architecture. Color images are very difficult to read. It also consumes a lot of data, a lot of memory space, right? So we converted all of those to grayscale. We did that pre-processing, and then we enhanced the image with equalization and filtering. We use that Gaussian filtering techniques that gave us better confidence. Yeah, this is what we should be doing, and this is what we found. So original image you see here, this is the pre-processed image. Original, pre-process, so you can see different distance. There is pothole, there is patching, there is cracking, and many other. You can see cracks here, right? You can see edge cracking, many others. So we had in total 1500 images coming from 3 different data sets, and our architecture also was able to detect the distress and label it using a label image tool that we used to train into the data set. So it was integrated with image processing. So we are using image processing and the artificial neural network. So it's a combination of both, right? And we were able to detect 18 distresses, 18 distress classes that I mentioned here, right? So you can see here 18 classes that we mentioned. And here are the results. You see here 87.44%. That's the highest in the world right now. Okay, the first of its kind in the world, in fact. So it's a globally validated now with, so we had 80% for the testing and 20% for the validation, which really worked out very well for us. You can see here 87 and 75%. That's really large. And we were able to capture all kinds of design. I can show you here. You see, it was able to capture the fatigue cracking, medium severity, patch deterioration, medium severity, transverse cracking, high severity, and then there are many others here. Let's see, EC, that's edge cracking, high severity, longitudinal cracking, low severity, and potholes, raveling. I'm just showing some pictures here, but it was really able to capture to the tune of 93 to 97% accuracy. That was the accuracy that we had. Then the other thing that we have done in the past with one of my students at IIT Kharagpur, we are able to capture the distresses based on the pavement condition. So we are able to capture the pavement condition. If you give us the data, we should be able to capture the pavement condition, and we are working on this. So we so one protocol that's there, ASTM, it's really not suitable for India. So we have actually published this document. If you want to go there and then see, so it's a prioritization. So you can see one of my students there, Ankit. He got his MTech from IIT Kharagpur. So he worked on this. This is the first of its kind in India, where we came up with the condition rating. okay, with engineering based criteria. So we developed our own data sheets for about 100 plus kilometers across Kharagpur and in Bengal state, right? So that's what. So we came up with these strategies for all kinds of maintenance there. The second, the third, the one, two, three, the fourth module, right? This is about the homogeneous sectioning. So you see, we actually came up with the road roughness prediction model. Again, used a deep learning network, and we were able to capture all of these. We input that. There are different layers, and we calculate the international roughness index. That's what we were aiming at, because LTPP database captures IRI. They have measured IRI, but what happens after a few years, that is not being able to, we are not able to do that. So our network can do this. This was recently presented by my student Nilansh, BTech. It's actually a BTech project that he did. Pavements is our PhD. So it was just recently, just last week, we presented this. And you can see here the mean square error is really, really low for about 473 data points coming from across 50 states in the US. And also the AP data set that was used for testing purposes. We tested that, and you see means square error is really, really low for that matter. Okay. The next thing, the last thing that I wanted to share with you is the homogeneous sectioning. Let's say you have 100 kilometers and you want to segment that into 100 sections, with each section having different distress, right? And you want to also segment this into various forms, such as 4 sections having similar distress, 5 sections having similar distress. That is called homogeneous sectioning. Okay, you are sectioning these roadways based on homogeneous distress pattern. So we came up with something called the SPURN, S-P-U-R-N, SPURN value, that combines 2 distresses. Currently, if you go to the literature, it's only uniparameter, which means one single parameter only can be detected. So we came up with one advanced version with different, okay, approaches, cumulative difference, absolute and control charts. We came up with the SPURN value, which gave us, okay, that's what is the APRDC data. For one section I'm showing you like this, we did it for entire section there, entire roadway stretch in Andhra. So you see here, we were able to segment this, okay, based on 2 different distresses. One is the rutting, the other is the roughness. So far, people have been successful in doing only one of these 2. We were able to capture both at the same time, right? So you come up with a, so that's what is this SPURN. So this is the definition. So you come up with the IRI and RUT. You come up with the homogeneous sectioning based on these 2 distresses. You have a threshold value, and then you calculate that. And finally, you arrive at the upper control and lower control limits based on the charts. And you segment those sections based on different color patterns and come up with the treatment strategies. That's what we have done. You see, if the value of SPURN is between this, you have a different treatment type. Or if it's greater than that, it's alarming condition, so you have to go for a reconstruction. So we were able to detect this using ANN. So it was also presented just last week in Smart Villages Conference, International Conference, and it's now going to be published also in some other journal very soon. So that's the 5th module that we developed. So here you can see all kinds of different colors. So these are the segmented things that we did based on IRI and rutting, right? Like this we did for every single thing. Now, where are we going? So again, come up with different research problems, please work on these. If you really require our help, let us know. We'll be glad to help you out. We are now monitoring various road classes. We have NHAI tie-up. So we have more than 200 kilometers stretch that we will be placing some asphalt rubber sections. In fact, we designed the entire IIT Tirupati campus. So we will be placing asphalt rubber gap section very soon, maybe in the next couple months, or maybe in the next 1 year, I should say. So we'll be monitoring the performance, long-term performance, and we need to be automating. As I told you always, the database is the major problem that we have in the country. We have data, what to do with it? That's the next problem that we have. So come up with the strategies, make use of the artificial intelligence. This is the order of the day. Use those tools. It's not just, civil engineers have always been thought to be, narrow-minded. That's not true. Now we are actually the most diversified group in the world. right? Civil engineers are the most diversified group. You name it, it's there with us. You have BIM. You people know what is BIM, I'm sure. You know artificial intelligence now. So several toolkits are there that could be used in our civil engineering application. And I want to talk about pavement. You can also do it for structures, water resources, environmental, and many other facets of civil engineering. And then the very important thing is just not doing in the lab. It has to go to practice. So we are tying up with SERC Chennai very soon, Structural Engineering Research Center, to monitor their thing and also come up with LCA toolkits for them. Okay, so because they've seen our publication, they came up with, we have an MOU with SERC IT Tirupati. So we are getting them more toolkits. See, I told you, getting a license is really costly. Instead, you create your own toolkits, much more cheaper, much more robust, coming from fundamental science, right? And then low impact development, I talked about this yesterday. Come up with field design specification. That's very important. Any agency will ask for this nowadays. And very importantly, not just building, but also manage the pavement assets, preserve those. How do you do that? You retrofit it, keep doing it, keep doing the maintenance, right? And calculate the econometrics. That's something very important that you have to do. Very important catch, please have the industry work with academia. That's the order of the day. Otherwise, I think we'll be in very bad shape very soon. Okay, that's a very good model. Again, this is yesterday I showed some of you who have not seen this. Please visit our lab, and then you should be able to get all kinds of equipment that are there. And I just mentioned to you some of the things: asphalt, rubber, pervious concrete yesterday, pavement asset management, warmix I didn't talk about, but hopefully sometime later. We didn't talk about this NHA project also, but we are coming up with new strategies there. I would be remiss if I don't mention these people again. West Bengal Highway Development Corporation, who helped us, and some of my students who now are working in various other institutions as faculty, they all were very kind to us. Engineers in chief from the West Bengal and also Andhra, right? Now my past students who are now faculty at IITs, plus IIT Tirupati director, who is my collaborator on pavement asset management, and AP RDC, several other people. So that's the end of my presentation. I'll be glad to take up any questions.
Thank you so
Thank
much,
you,
Dr.
sir.
KRISHNA Prapoorna. Excellent speech.
Thank you very much.
Nice. So I loved it. Like, because I am also working in artificial intelligence right now. So
Thank you.
I'm happy. Like, I will meet you. I'll meet you soon.
Sure,
Thank you.
please.
Please, Shannon Priya, you can send the link to
Yes,
the
sir. I'm online, sir.
participants. Yeah, and participants, you can post your questions, please.
Yeah, I can see one question. Have you measured IRI? No, we haven't measured IRI yet. We haven't done, but it is there with the data. APRDC has done that. They've done the roughness calculations. That's not exactly IRI. It has to be converted to IRI. That's the answer to your question. Any other questions? You can ask me. You can can they unmute and then ask me? That's okay.
Good evening. This is Dr. Asha from St. Peter's Institute of Higher Education and Research, Chennai.
Please.
Your lecture was very new one, like use of artificial intelligence in civil engineering. I think it's a growing area. Since we are not familiar with this artificial intelligence, if we want to do some projects in the artificial intelligence, what basic knowledge or skill we should have, or what should we refer to do some projects in artificial intelligence?
Yeah, most of our group members, what they're doing is they have some basic idea about MATLAB, Python, because they're writing most of the codes in Python. Okay, and C++ will be very useful. So this is basic thing that you need. And then some artificial intelligence tools that I showed you. One of them is YOLO, YOLO. That's you only look once. That's a software toolkit. They're all available. They're all open source, Dr. Asha, if I can.
Yes, sir. Yes, sir.
Yeah, so they're all open source software tools. So go there, you Google, you should be able to get that, start reading. They have manuals with them. So you should be able to do that.
Yes, sir. You have shown some photographs of the pothole images. Is it, why should we go to the high resolution images? Why can't we go with the ordinary photographs or?
They are ordinary photographs, madam.
They are not like you are saying data processing, something you are saying.
Yeah. Actually, what happens is, you see, it is having very high resolution. But the thing is, you need your architecture should be able to detect the pixels, right? If it is
Okay,
really, if it is not that, if it's not processed, then it's going to be difficult.
okay,
And color images are very difficult to be read by the toolkits. You can ask Dr. Rajan, maybe he's an expert. I'm not an expert in artificial intelligence myself, but we're working on it. The thing is, colored images will take up too much of memory. You need to be converting that to black and white. That's the easiest way. And black and white is what is easy to detect the cracks. Otherwise, you'll be detecting some other colors, which may be, the oil spill may be colorful, but that could be detected as a crack. You don't want to do that, right?
okay,
So,
okay.
yeah, so that's where we, that's why you need to be pre-processing it.
Sorry to interrupt,
Thank
sir.
you.
Sorry to interrupt, sir, Doctor. Asha, madam, soon
Yes,
I
sir.
will arrange. Soon I will arrange a one-day workshop on artificial intelligence pertaining to construction industry. So I have already I planned for that. So we will make it. We'll make it soon, so
Oh,
that you
fine,
all your
fine, fine.
doubt will be clear. What should be learned by a civil engineer? What should be learned by a civil engineering faculty? What are the issues and challenges which could be converted as opportunities using artificial intelligence in construction industry, not only in highway engineering, but then to
Yes.
all a 360-degree sphere of construction industry. We are going to give a planning a workshop. We'll do it. Okay, I will.
That's
I
wonderful.
will tell you. Thanks, Krishna. So that you also told her to ask me, so I use this opportunity to share this in
Sure,
the forum.
absolutely. I think that's a good thing. There's one question I can see. Can we use the asphalt rubber as surface material for pervious pavement? Pervious pavement, that's what is asphalt rubber. Friction course is an open graded friction. It's an open graded structure. It's a pervious. It's a pervious layer. Yeah, of course you can use it. It can be used in any layer. Yeah, any other question? Please go ahead. That's fine. I can answer. Let's see, can these AI software, by the way, there is no plural for software is software. For all of those who are here, plural for equipment is equipment. Plural for software is software. Plural for aircraft is aircraft. Don't use aircrafts, don't use softwares, don't use equipments. They're all singular, plural is similar. Sorry, I thought I should say this. Used for monitoring.
What should be told should be told. I think
Used
we will
for
take it the right
monitoring, used for monitoring strength of ground, improved pavements. Yeah. People have been doing this. They have been doing with. They're using AI tools for compaction, intelligence compaction. They're all using it. Of course, they're using it. Shabari Kalyan.
Yeah, recordings are already available. We will share it to everybody. All YouTube. We have YouTube streaming. We have all the video sessions of this
Great.
program is being recorded. We will edit it and send it to the participants. Definitely will do it. Okay. Thank you. Sir, can you, I think you will, hope you will share the presentations in the non-editable mode.
Yeah, I will do that. I will do that.
Please.
Yeah.
Yeah, so that I will share to the participants. Yeah, after the end of the program, I used to normally send us a link like all the PPTs.
Okay, we will do that. Give me one more day. I will.
Yeah, no issues. Take your own time, sir. Take your own time.
Any other
Anything
questions?
else? Any questions?
You can just raise your unmute and ask me. Yeah. So apart from these people, there are also people in the YouTube, is it?
Yeah, true. Some people are there in YouTube also.
I see. Okay.
Because we made such a way that when the people can go on their own convenient way, no, like that.
Great. Makes sense. Yeah. Yeah, looks like they're all tired.
Yeah. But no. Actually, your talk was very energetic, and the very buzzword artificial made them to rise up. People are quite interested to learn something about it. So you paved away. This is the first resource person who has talked about AI in payments. So thanks a lot, Krishna, to share that area which we are already working dynamically. Very great of you. Had a wonderful 2 sessions we had from you. We think we can have more such things in the future. We can work together. Thank you.
Thank you very much, and good wishes to every one of you. Please be encouraged. We have excellent resources in the country. Make use of it. Use all the resources that we have. Train yourself. Get equipped, and do good job. Very good. Otherwise, I sign out now. Dr. Rajan?
Yeah, I think so. Okay.
Thank you very much. Thank you.
Have a good day. Participants, as usual, my request, please share your share your all the feedback. Please click the feedback link, share your opinions, thoughts, fill the feedback forms. If you have any specific questions or specific interest, you can mail me regarding this artificial intelligence. As I told in this forum, I will definitely will make at least a one-day workshop. I will arrange with eminent experts who is working on the field. And I am also working on this, started working on this field. I want to inform you. So that's why I'm trying to coordinating all the experts who are already doing some work in this, and let us have a beautiful session on artificial intelligence pertaining to construction industry in the near future. We can do it. Fine. I hope you all will attend it and get benefited. Thank you. Thanks a lot. Thanks a lot to all of you. Let us meet tomorrow. Fine.
Okay. So thank you,
Bye,
sir.
Thank you, Priya. Thanks a lot.
Sir.
Bye.
Yeah, thank
And
you,
share
sir.
the links in the WhatsApp group also, so that people can, who are not just now available, would have went for some other job, they also give their feedback. So share it in the WhatsApp
Yes, sir,
group
we shared,
also.
sir.
Yeah,
We shared.
thank you. Thanks a lot. Bye.
Thank you, participants. The feedback link is shared in our chat box, and I request you all to attend our tomorrow session by 10 o'clock.